Hey Chem Kids, Campbell here. In our first video on Chapter 12, we're going to talk about the states of matter and inter- and intramolecular forces. So if you remember back to Chapter 13, we talked about kinetic molecular theory and how molecules are in constant random motion, and if the higher the temperature is, right, the more kinetic energy they have. And this applies to states of matter. All right, a solid, which is, real compact and it's not moving, the molecules will vibrate a little in the solid, but so they have the least energy and the least movement. We go to a liquid, right, now we have some more disorder in the system, they move around more, so we have a medium amount of energy and movement, and of course a gas has the most energy, right, it's all over the place. And if we think about any substance, as we increase its temperature, we're increasing the kinetic energy, and that's why they change from solid to liquid to gas, right? In the winter, water is ice outside when it's cold, and then it'll melt, and if it gets real hot, right, we get water vapor. It gets real humid in the summer here, and so we've got water vapor. Now, we need to talk a little bit about the properties of liquids and solids before we actually talk about some of the forces between them. And the first property is called vaporization. What vaporization is if we have a liquid and some of it evaporates and creates vapor, so it becomes a gas. That's called vaporization. And you need to know that because you need also to know the definition of vapor pressure. And what vapor pressure is once I've got these molecules above the liquid, I've got vapor above the liquid, it'll bounce, right, and exert pressure onto the surface of the liquid. So here we have an initial condition where I have water, and here's a U-tube with mercury in it, like a manometer. And if we start, this water starts to evaporate, right, I start getting water vapor, and that water vapor exerts a pressure. So notice that the line of mercury has gone down. So I've increased the pressure in the flask. And the more that happens, the more pressure it creates. And one of the things that will increase the vapor pressure is if we increase the temperature. If we increase the temperature, I've got more movement, more molecules can escape the liquid and join the vapor. Another thing you need to know is boiling point. Now, I know that you probably know that something is boiling when you start to see the bubbles forming in the liquid and coming to the surface, but you probably don't know what exactly a boiling point is. What a boiling point is, it's a temperature at which the vapor pressure, the pressure of the vapor, is equal to the atmospheric pressure. So when that happens, all the bubbles can rise up. And it always starts at the bottom, right, because that's the part where we're heating, when we're heating a substance, like a pot on a stove. Now, because atmospheric pressure varies with elevation, right, the higher we go, the less dense the air is, so it's going to have less pressure. That means that the boiling points actually change. So if you look at sea level, which is actually where most of us live here in Missouri, the boiling point of water is 100 degrees Celsius. Well, if we go to the top of Mount Everest, or maybe Mount Denali, because that's in the U.S. and Alaska, the boiling point actually drops to 79. So I don't have to heat it as high to make it boil. Of course, I expect that you know what melting point is, right? Melting point, here we are skating. Melting point is the temperature at which a solid goes to a liquid. So what determines at room temperature why some substances are solids, why some are liquids, and why some are gases? Well, the state of a substance depends upon the forces that are holding it together. Solids must have at room temperature must have a really strong force compared to liquids or even gases. Gases must have really weak forces. And there are two types of forces. There are intramolecular forces. Those are forces between atoms. Those are the chemical bonds. Those are inside the molecules. The other type are intermolecular forces. Inter is the force between molecules. So intra is the chemical bonds inside. Inter is between molecules. So you can kind of think about it like an introvert is someone who's really inside themselves, really quiet, keeps to themselves, where someone with good interpersonal skills is good with other people. So intra, inside, inter, outside. Now, there are 4 categories of solids that are named for their intramolecular force for their chemical bonds, and you need to know what they are and how to identify them. So we're going to go through what they are, and then we'll go through more specifics. So there's ionic, there's metallic, there's covalent network, and there is molecular covalent. And in order for them to be solids, they have to be pretty large. So let's go into detail about each of these. So an ionic solid, you'll need to be able to identify an ionic solid. So it's anytime we have something that's ionic, it's a metal, that side of the periodic table, bound to a nonmetal up there in the periodic table. Or you could take an electronegativity difference from your periodic table, and if the difference between the 2 atoms is greater than 1.7, it tends to be ionic. Now, some good examples are like table salt sodium chloride or calcium chloride sodium fluoride. So the first one is the metal. There's my nonmetal. Some of the properties that you also need to know is that ionic solids have very high melting points and boiling points. So if I want to get like sodium chloride to be a liquid, I'm going to have to heat it really high. They're also very brittle. They break very easily. And they're non-conductors when they're solid. So if I just take table salt and I try to run electricity through it, nothing's going to happen. But if I dissolve it in water and it becomes a liquid, then it will conduct electricity. So not as a solid, but as a liquid. If I dissolve it, then yes. So those are ionic solids. Then we also have metallic solids. So a metallic solid is a metal by itself, like iron or copper or silver or gold or any of the stuff over here when it's all by itself, not bound to something else. One of the properties which makes metals very unique is they have a sea of electrons. And what that means is that the electrons aren't bound to the nuclei. They're not bound to the protons they came in with. But they're actually free to roam all the way around. They're kind of like wanderers in the metal. Metals have variable hardness. Like when we were doing that lab with the lead and the zinc, the lead, I could tell it was lead because lead bends really well. But zinc is really hard. It's not very easy to bend. They also have variable melting points. Malleable, which means they're bendable, and they are conductors. So when we run current through a metal, because we've got this sea of electrons, we'll generate electricity. So that's why your houses are wired with copper wires. Copper's a metal. Covalent network is a special and very unique type of solid, and it's when atoms are covalently bound to each other. Good examples of that are diamond and quartz. Diamond being all carbon atoms, and quartz is silicon with some oxygen. But their properties, they're very high melting point, right? Diamonds are like indestructible, almost. They're very, very hard, and they do not conduct electricity. Our last type of intramolecular force is called covalent or molecular. How do you identify them? Are there 2 nonmetals bound together? So 2 of those guys up there bound together would make it a molecular covalent compound. Or when you take an electronegativity difference between them, it'll be less than 1.7. Now, if they're solids, they're very large molecules, like this wax here of carbon and hydrogen. Or here's sugar. Sugar's covalent. Look how big that molecule is. So some good examples are sugar. Ice water is actually a molecular compound. It's a solid when it's cold. So that's the low temperature part. Dry ice, which is frozen carbon dioxide, wax that you use your candles with. So covalent, not 2 nonmetals bound together. And they're solids if they're big molecules or if they're really cold, like water and ice. Properties, they're soft, much softer than any ionic or metallic substance. They have low melting and boiling points, relatively speaking, and they do not conduct electricity. Now, molecular compounds or covalent compounds, their state depends upon more things, right? All ionic compounds are solids. Most metals are solids except mercury. That's the one exception. But for our covalent or molecular compounds, the state of the substance, whether it's a solid, liquid, or gas, depends on a couple things. The size of the molecule. If it's bigger, it's going to be a solid. Temperature, if it's really cold, it's going to be a solid. And the intermolecular force, or what I call IMF. There are three types of IMFs: hydrogen bonding, dipole-dipole forces, and dispersion forces, and we are going to talk a lot about them in class. So, what I'm going to leave you with is a learning check. See if you can identify what type of intramolecular forces are in these compounds. So pause the video, see if you can figure it out. If you got it right, you said that lithium fluoride was ionic, metal bound to nonmetal. Au, that's gold, metallic. There's glucose here, molecular. Water is also molecular, and diamond is our covalent network. How'd you do? I'll see you in class, and we're going to talk about intermolecular forces.